great. Okay, so what you just saw was the flash of a, let's get this right here. What you just saw there was the flash of a ignition bomb, all right? And my buddy Alex is setting it up to do another test here in a minute or two, but let me tell you a little bit about what it does. This is a chamber, it's a steel chamber that we're filling with a mixture of air and fuel, and then igniting with essentially a spark plug. And this test is intended to show how much energy it takes to ignite fuels of different mixtures, where those mixtures would range between the lean limit and the rich limit of flammability. If it's beyond those limits, then we don't expect it to light at all. What we do expect to see, however, is that the energy required from the spark plug to ignite the mixture will go down as we approach that stoichiometric balance of fuel and air. And as we move out to those lean and rich limits, we would expect to see the energy required increase. So the test you just saw was the actual explosion resulting from, let's not say explosion, let's just say reaction resulting from the mixture of methane and air being ignited by the spark plug. So what Alex is doing now is pulling down the pressure in the chamber using a pump that's removing the products of combustion. He'll do that several times, suck it down, and then fill it up with air to 4 or 5 atmospheres, and then pull it down, fill it with air to 4 or 5 atmospheres, and that purges out the products of combustion. Then he'll fill it up again with the mixture of fuel and air. And the way they do it for this particular application, they've gotten pretty good at it. They fill it up with about from 0 atmospheres, let's say. You know, we don't really pull a complete vacuum, but at about 0 atmospheres, they fill it to 1/10 of an atmosphere with fuel, and then the rest of the way up to 1 atmosphere with air, okay? And that then gives them a mixture corresponding to, we hope, something near the stoichiometric point for a methane-air mixture. I'll pull the camera off and show you the details of the assembly just so you know how it's put together. Okay, so what you're looking at is the bomb itself with a something like a big spark plug in there. It's actually 2 long pieces of steel that are pointed at the ends and spaced a bit of a distance apart from each other. Those electrodes are attached to just a regular old spark plug, like in your car, and the spark plug then is attached to a coil, just like in your car. Okay, and at the top of the bomb combustion bomb is a pressure transducer, and the pressure transducer is giving us a continuous reading of pressure. So, and that does 2 things. One, as they fill the chamber using methane and air, and if you remember we talked about rotometers, they're filling using these rotometers, and one corresponds to fuel and another corresponds over here to air. They're tracking how much goes in by looking at this LabVIEW program. So Alex has filled it to an atmosphere, and this has given him a reading of the pressure. When he actually runs the test, he's probably going to do a bit of a different LabVIEW program so he can see that large spike in pressure that results from ignition. So I think he's ready, and we'll have another look and see what we get. And I'll pull in as close as I can. Hey Alex, while you're over there, would you mind toggling the circuit diagram in the LabVIEW program? Sure. For those of you who don't know, LabVIEW is a program used to collect data. It's widely used, and I don't know if you can see the circuit diagram that has been built by these guys here in the lab to do the data acquisition here. But what it represents, sort of in a virtual way, is a data act card on the left, and they've compressed the signal with a sample compression unit, and then they have some kind of a timer that they're using there that they've built into the program. I don't know what that's for. And then it looks to me like that's their pressure transducer, and then some other timing unit, and a processing box that is what is that one for? Is that just giving you your output to the screen, Alex? That last box on the right there?
Yeah, I think so.
Okay.
So you know all the signals are inside the DAC assistant here.
Right,
so
right.
We're reading pressure transducer, and then the timing is just so we have an elapsed time, so it actually kind of does like a strip chart and it plots it.
Okay.
So yeah, that's
Great. All right. So the DAC box there is a sub-program within LabVIEW that contains the ability to read their pressure transducer and the voltage. Is that right? Just voltage?
I can open it up and we can see kind of how it's.
All right. Give it a second. He's just going to open that sub routine within LabVIEW, and we'll see what we have there.
It's really all it's reading here is the pressure transducer, which is ATM for atmospheres. Is kind of what units we're reading.
Great.
Maximum and minimum voltages of, so it's 10 volt max, negative 10 volt minimum, depending on how you calibrate it. And then it's all plotted through a graph here and a scale that we set up for voltage. How much voltage is equal to how many atmospheres, basically.
Okay, sounds good. Thanks. All right, so we'll pop this back onto the tripod and see if we get another reading, get another test, and I'll show you the results on the screen. And what you're going to hear is some clicking that Alex is manually triggering the coil to get this thing to go off. So let's see what we get. And I'll come in nice and tight and you should be able to see pretty well.
You ready there, Dave?
Yep.
All right.
Okay, there it goes. Okay, that's it. Thanks, Alex. This is, you can see, oh, and here's the, let's just show you the output on the screen here. So there's your pressure spike that corresponded with that ignition event. And this is showing a pressure of 6.5 atmospheres. Actually, maybe a little more. Yeah, about 6.5 atmospheres up there. Okay, good. That's it. Thanks.